So today we'll be trying to create a data feed using R, and we'll use Alpha Vantage's API tool to request the data. So go ahead and register for your own API key, which we'll need for this script, and go ahead and get started with this. So for this one, it's kind of short. You just need two packages, data table and quanmod, and a couple functions. The first one is to get data, to request it. So here the arguments will be symbol, what symbol you're trying to call, the interval, and of course your API key. Now for the URL, go ahead and paste. Alright, so I'll leave the link to use down below. We need to split this up. So right after the equal sign, we'll put a quotation. And then right after this equal sign, and then right after this one as well. And then just replace the ones that they have here. It is symbol, interval, API key. So that's our URL. Now we're going to read the data in using fread, which is supposed to be faster. True set. Fread there. Now so just some cosmetics. Basically what I'm doing here is trying to add a column, and each row of that column will have the symbol's name. So just in case you're trying to save this in a database, you could quickly reference it. And then this line here, we're just trying to convert it into an extensible object. So here it's open, hi. We're going to order by the timestamp. Then here we'll put in the format that is currently displayed in. So 4-digit year, the month, the date, then hour, minute, and second. Next, time zone. It'll return New York. then finally just return the data as an XCS object. So there's that. Next, what we'll need is basically to determine the next trading day. So we'll do day to day function, empty function. So we want to know what time it is now. And then we're going to write this statement here. And I'll explain what it means right now. Since the market has already closed, say I was trying to run something that requires my data feed. So what this function will do is determine the next trading day based on the current time. So if it's greater than the market close, time, but less than midnight, then we want to trade the next trading day, which is symbolized here. So today plus 1, it'll be tomorrow. If not, then just return today. Good. So that's it for this one. This is going to be our function for computer sleep. So it's gonna, if you want to use this data feed to run some script that requires that data, and since you're calling it every minute, we're going to put the computer to sleep. So here we're going to put sleep as function. Market hours. It's going to determine how much to sleep based on our current time, basically. Hours, minutes, seconds. We want to return the attribute of our current sleep time, of our current time actually. That's numeric. And then here we'll make the determination. So if hours, minutes, seconds is hours, print Then we're going to print a statement if the difference is in minutes, we will print a separate one. And then if the difference is in seconds, we'll print a different one. And in each case, we'll have a requirement to sleep for a certain amount of time. Here, we'll just print it out so that we know that it's actually running in the background. So here we're gonna, if difference is in hours, we're gonna put the computer to sleep times 60 for seconds and then 60 for minutes. And then we're going to actually just copy this, paste it here. If it is in minutes, just gonna put the computer to sleep in minutes. And the last one will be seconds. And that should be it for that function. Alright, so now for the actual scripting here. So first we're going to put in our API key, which you will get once you sign up. And then the time intervals you want to return, we'll put in a minute. And then we're going to call in our function to determine what trading day we want to start at. So we'll just run our functions here. So here we see that the actual trading day is 5/12. Today is 5/11, and it's after market close, so it's correct. The next market open is basically tomorrow. And then we're going to make a sequence of times. So the starting time, for me, I'm located in the West Coast, so you might want to change this depending on what time zone you're in. But here we'll do so for me the market opens at 6:30 a.m. and the starting point will be tomorrow at 6:31. And then what time does it end? Put this one here. So for me it ends at 13 hours. It's good. So now we're going to make our sequence. Start, end, by paste 0. Time in force, which is 1 minute. We'll run this. Oh. So now if we check market hours, we see our sequence of time intervals basically, all spread out by a minute. So that's good. And there should be 390. Yes. And I'm just going to put this here so that if something breaks, you could just rerun this previous code and it should pick up the next bar or next interval. I want to return all the intervals greater than right now. So here we do sleep 1, scan, you know what, I'm gonna add something. I'm gonna add a package. So if you could require pb apply. It's just the apply function family, but with the progress bar. So here we'll do as list to length of market hours. And then our function will be data, get data, symbol, try Amazon, interval 1 minute, API key, be our API key. Alright. And then I'm just going to print out the data, but basically you could do anything you want between the market hours inside this function here. But for this tutorial, we're just going to print them out. So I'm going to head and enter my API key and then run this just for testing purposes. Alright, so I've entered my API key. So here we'll run this again, time in force 1 minute. The next trading day will be tomorrow. Start and market hours, and then we'll sleep. So when you run this, you want to run. So when you run this, you want to run this as well. It's just going to determine when to start. So if we run it, now we see it will sleep for approximately 15 hours, and it'll begin at this time. But we'll go ahead and delete it, because we don't want to run it now, we're just testing it. Data, get the data here. Object that not found. Oops, made a mistake here. So now it should work. So now we have our data, and then we'll print the tail of it basically. So there we have it, and then it'll iterate through each timestamp, and depending on which timestamp it's at, we'll put it to sleep. So let's see. So say we were at 6:31 in the morning tomorrow. It'll run the second one and see what it says. It should start on at 6:32. So it'll be 6:32. Alright. So I'll run this tomorrow and see what kind of results we get. I changed the time enforced to 5 minutes because the 1 minute saw a delay of about 2 minutes, but I see no difference. Here, if we change the time enforced to 5 minutes, I'm still getting the 2 minute delay. So it looks like we are still getting the 2 minute delay. I'll go ahead and check. So it should have been 290.44 at the close. If we check here, we get 290.50. Let's see, 290.50. $290.50 was for the previous bar. We check the prior bar. We have a close of 290.39. And this one is saying 290.61.50. Yeah, so it looks like it is 2 minutes behind. Here at the close on the 17th, we have 290.44, so the previous bar should be the 61.50. Yeah, so it looks like it is behind 2 minutes, not real time, but I guess it beats the 15-minute delay. So you could change the time enforced to a minute and leave it there. I just thought that maybe a lower frequency might yield a better result since we weren't calling it as frequently, but that is not the case. So if you have any questions, leave them down below. Other than that, thank you for watching.